to Python Programming Session 30. In this session, we are going to discuss about exception handling in Python. Here, we discuss about type of exceptions, assert statement and except block. Exception. Exception is an object that represents an error. So when we say exception, it may be a runtime error or it can be an abnormal condition that may arise in a program during the execution. And when it is raised, an exception object is created and the programmer should write a code to handle that exception. If not, the program will terminate abnormally. If the program terminates abnormally, we say the system is not reliable. The program is not reliable. So, we have to write a coding so that the system never fails or the code never fails in any abnormal situation so that the system will be robust. So, the job of the programmer is to guess all the abnormal situations and have to write a code to handle that particular situation. This is what we call it as exception handling. For example, consider this 10 divided by 1 by 0. So anything divided by 0 will generate an error, that is divide by 0 error. When such situation occurs, the code will stop the execution and the program will be stopped abruptly. So to handle the situations only, we are going to write exception handling codes. Consider one more coding. We are going to say x is equal to 5 plus spam. Spam may be any variable. But you don't know what is the value of spam means. In that case also, it is going to generate an error. We call it as the name spam is not defined. Or you can also say variable not defined error in other languages. Consider this situation. We have x is equal to 10, y is equal to 10 plus I. In this case, we are going to get an error unsupported operand type for plus. Like this, we are going to get an error. So these are some situations where the error is going to occur only during the execution. How to handle these exceptions? Exception handlers must be defined and it should be separated from the main logic. So main logic should be separate and the error correction and the detection code should be separate. And the code which handle the exception should check for all the possibility of the error, and if there is any exception, then the particular code should be executed to handle that particular exception. If there is no exception, then the main program will be executed without any error correction codes. If there is no errors, then the main logic of the program will be executing. So the compiler or the interpreter should keep track of where that particular error is generated and it should handle that particular error. So this error handling can be done for both user-defined and built-in functions. Let us see how to handle this exception. So the first one, an error is encountered in the method means then it should create an exception object. So an object is created. So this object will raise an exception. So exception is raised means, so then the runtime system should search for the exception handler, and if it is found, then it will execute that code. If it is not found, it will search for the method in the call stack and it will just go for program termination. If the exception is found, it will execute the code and it will continue with the normal execution. This is the step to handle the exception. Let us see how it is handled in Python. It is done by using the statement try and except statement. So first, the try class. It contains the set of statements where the exception may arise. It should be followed by an except class. Except class is skipped if there is no exception. So this can be somewhat similar to your try and catch block in your C++ and Java. So here we call it as try and except. If an exception occurs, the remaining part of the try class is skipped and it will search for the matching exception, and if it is found, it will execute the part of the except class and it will continue after the try statement. If the exception is not matching, it will become unhandled exception and the execution stops. So if there is no exception, then execution will be smoothly done without any problem. If the exception occurs and the match is found, then it will execute the except code and it will continue after the try statement. If an exception is not matching with the except class, then the unhandled exception and execution will stop. This is the procedure for handling the exceptions in Python using try and except statement. So let us see the syntax of try and except class. Try. Try is a keyword which is followed by a program statements where the exceptions may occur. Remember, there should be a proper indentation. So whatever given in this particular level of intent will be considered under try class. Then we have an except class. Exception name can be given in the bracket. Then here the code for exception handling if the exception name error is encountered. Here also you can notice there is a proper indentation. So this except block or except class should be always should follow only the try class. This except class cannot exist alone. Consider this example. This is a simple demo program to show the use of try and except class in Python. Try colon numerator is equal to 50. Denominator is equal to int of input enter the denominator. So we are going to get the input for the denominator from the keyboard. Quotient is equal to numerator divided by denominator and print division performed successfully. Now, in except class, if the zero division error occurs, if the input value is 0, then it is going to generate an exception, zero division error. Now, if an exception occurs, then I say print denominator as 0, not allowed. Then print outside try except block. Now, imagine that the input for the denominator is going to be 5. So, if the denominator is going to be 5, then quotient is equal to numerator divided by denominator. So, it is going to give the value 50 by 5 is equal to 10. Now, the result is 10. So, it will print division performed successfully. If not, if you give the input not a number is 0. If you give 0 as an input, then we are going to say 50 divided by 0. This is going to be infinity. So it will generate an exception. Once an exception is generated, the control will be passed to the except block and this part of the statement will not be executed. So if an exception arises in the code given inside the try class, then the remaining part of the try block is skipped and the control will be passed to the except block. It will search for the matching with the error. Yes, we got zero division error. So it will print denominator as 0, not allowed, and then the control will come out of this try block also. So it will print outside try except block. So depends upon the input, it is going to perform the operation. So if the denominator is not 0, it will print only division performed successfully. If the denominator is 0, then it will print denominator as 0 and not allowed. In both the cases, whether the exception arises or not, we are going to print this particular statement. That is, print outside try except block. So the program is not going to terminate abruptly or abnormally. It is going to execute the statements following this try except class. We can also use multiple except statement in our coding. In some cases, we can also have except statement without specifying the exception if you are not sure about what type of exception it is going to create. Let us see an example. So here, try block, numerator is equal to 50, denominator is equal to int input of enter the denominator, and quotient is equal to numerator divided by denominator. Division performed successfully. Except value error. So value error will be generated if the input is not going to be an integer. So here we have to print only integers should be entered. If any other exception arises inside the program, that you can handle by using an empty except statement, that is print oops some exception raised. So now we are going to have more than one except statement. Here in this example we have two except statement, and this is a generalized except statement without specifying an exception. So like this you can use multiple except and except without specifying exception in our coding. Let us try this example. Let us consider one more special case. Here, the try except class can also have an else class. You remember, we have for loop and while loop with else class. Here, even the try and except class can have an else class. How to use it? Let us see. Here, try numerator is equal to 50. Denominator, I am going to get the input and I will assign it to the quotient is equal to numerator divided by denominator. And I will print division performed successfully if there is no error. Otherwise, except 0 division error. If the input is 0, then the control will come to 0 division error and we will print denominator as 0 is not allowed. One more exception, except value error. If the input is not an integer, then you will get an error except value error and we will print only integer should be entered. Now, it can be followed by an else class. There, the result of the division operation is quotient. Here, this else class will be executed if the exception is not going to occur. The try block will be followed by this else class. If any of the exception occurs, then this else class will not be executed. If an exception occurs, the control will come out of this try, except and else. This is the outside of try and except class and the execution will continue. This else class will be executed only if the try block completes the execution of all the statements without any error. That is the use of try, except and else class in Python. This is one of the special case which we have not discussed in our C++ and Java exception handling. We were discussing about some errors like value error, zero division error and so on. These are some of the built-in exceptions in Python. So Python standard library is having a huge collection of exceptions, built-in exceptions to handle the commonly occurring errors. Now, we will discuss few built-in exceptions and its usage. The first one is syntax error. The syntax error is raised when there is an error in the syntax of the Python code. Second one is value error. This error is raised when the right data type is not provided as an input. The third one is IO error. This is raised when the file specified by the program statement cannot be opened. If the file specified cannot be opened, it will give you an error, IO error. Keyboard interrupt. It is raised when the user accidentally hits the delete or escape key while executing a program, due to which the normal flow of the program is interrupted. Import error. If the requested module is not found, then it will generate an import error. So you remember, whenever we want to use some module, we used to import the module using import statement. Import numpy, import abc, and so on. EOF error. This will be generated when the end of file condition is reached. That is EOF error. Zero division error. As we know, if the denominator of the division is 0, it will generate a zero division error. Index error. If you are using an index or a subscript for a range which is not a valid, then it is going to generate an index error. Name error. So when the local and the global variable or name is not defined, then it will generate a name error. Indentation error. So if you are using incorrect indentation in your code, then it will generate an indentation error. Type error. When the operator is supplied with the incorrect data type, it is going to generate an type error. Overflow error, that will be raised when the result of the calculation exceeds the maximum limit for numeric data type. This is an example for, these are the examples for built-in exceptions in Python. Now, let us see how to raise or create an exception during the execution of the program. So we can do this by using raise statement. So this raise statement we have discussed already in different types of statements or jump statements in Python. This raise statement can be used to throw an exception. Syntax is raise exception name. If you want, you can pass some arguments also. So the argument is generally a string that is displayed when the exception is raised. The error detected may be built-in exception or it may be a user-defined exception. So Python always displays the stack traceback, so which will give the sequence of functions calls made and the execution of the code which created the exception. Assert statement. Assert statement will check for a particular condition. If the condition is true, then the program will keep running. If the condition is false, the program will return an assertion error. So the syntax is assert condition followed by an optional message. So the condition means, here the condition for which you want to test will be given and display upon the execution of the assert statement will be given as a message. Let us see an example for this assert statement. X is equal to 10. Assert x greater than 0, print x is a positive number. So we saw already, if the condition is true, then it will execute that particular statement. If not, it will create an error. So the output will be like this. So it will print x is a positive integer. Here, if I say x is equal to 0, assert x greater than 0 means x is a positive integer. Now, x is not greater than 0, x is equal to 0, then it will generate an error that assert x greater than 0 is creating an assertion error. Like this, you can use an assert statement in your coding. You can refer these books and websites for more information. Have a nice day.